hosting us today. Really excited to be talking to you. And we have been working in the area of 3D printing for almost 3.5 years now. And we are based out of Chennai in India, southern India. And we have been building an end-to-end solution to cater to the affordable housing needs, especially of India, and also hosting us today. Really excited. So we started, three of us, a few years back, building small 3D printing solutions, but we felt that the greatest opportunity that where 3D printing could really contribute was in the construction space. And that's how we started developing the solution. And I'll probably start speaking about why India really requires something like 3D printing to solve its affordable housing needs. So if you have seen, construction all across the globe, and especially in India, nothing has really changed for the past 50, 60 years. In India, especially precast and other construction technologies are spoken as if they are new technologies, whereas precast really has existed in this country for almost 60 years and has been not able to penetrate into the construction industry in general, and especially the rural market where majority of India's population resides. India requires about 100 million houses by 2030, and the government is planning to build about 20 million houses by 2022. If we are to solve this problem, it is going to be solved only through technology, and that is where we want to come in. We want to provide a complete shift in the way affordable housing is viewed, and we want to enable that for a majority of India's population as quickly as possible using 3D printing with a sustainable and speedy solution. So that's what we are working towards. And this is, in essence, what ails the construction industry. So if we have looked at the productivity charts, especially in the manufacturing and construction space, for the last 50 years, nothing has, in the construction space especially, nothing has really changed. That's because of the lack of automation that has been there in the construction space versus manufacturing, which has quickly adopted CNC machines, robotics, database technologies, and moved forward with its productivity. Whereas construction industry has been sort of lacking with that. And especially in a labor surplus market like India, construction has relied on a surplus of skilled laborers to execute its projects. And this has not been able to deliver the kind of solutions that the affordable market requires. There is capital, there is land available, but this is one of the very rare industries which is constrained by a supply side problem. So this is what we are intending to tackle with automation. So I would like to just show you a brief video to just highlight what the problem of housing in India really is. I'm not sure if you're able to hear my audio.
We are not, but maybe you can sort of voice over or talk us through this.
Moment. Yeah, just give me a moment. I think
you can try to, if you try to click on your photo, I believe there's a button that will let you share your computer audio.
Yeah. I hope you're able to.
Yes.
Yeah. So the condition of, especially the urban and also the rural poor in India is extremely bad. The kind of housing that they live in, they are absolutely exposed to the elements, and during natural disasters, they are the ones who suffer the most.
लोन के लिए सोचा, बाकी तो कुछ सोच नहीं पा रहा हूँ, लेकिन लोन भी इतना अमाउंट होता है तो लेना बहुत भारी होगा। सपना है लेकिन सपना पूरा नहीं कर पाते हूँ।
अभी इतना है, अभी हम लोग कितना 100-200 रुपए कमाते हैं घर में, उसमें तो 50 रुपए चाय का पकड़ लो, 100 रुपए खिचड़ी पिचड़ी सबको पका कर 50 रुपए चाय पचाए, सब बच्चे लोग को हो जाता है खर्चा। अभी हम लोग इतना 2-3 लाख रुपए कोई मांगेंगे तो हम लोग कहाँ से ला देंगे? ऐसा है, इसलिए हम लोग इधर रहते हैं।
So the housing problem in India is multifaceted. There is an issue of financing, which the government has tried to address. So, for example, for the housing mission that they currently have, they were planned to build about 20 million houses by 2022. Of that, about 6 million were grounded, in the sense financing was arranged, the land was arranged, but only about zero 0.8 million was actually built. So even after the financing solution was, the financing problem was addressed, and even after land being available, all the legal aspects being taken care of, the execution is absolutely not to the level where 20 million houses can be delivered. So that is where we feel technology-based solutions can really make a difference. And we need a technology that is really portable, that can travel from location to location, that can enable construction not just in the urban centers, but in the rural areas where almost 60 to 65% of Indian population really resides. So that is why we are developing a solution that is independent of supply chains, that can travel to rural areas and deliver urban quality construction in rural areas, not just any kind of construction. So this is the vision with which we are working to create a tangible improvement in the life of individuals with a shelter. And as I mentioned, India requires this solution and the world requires this solution. Frankly, I was just, in the speakers roundtable, I had a wonderful conversation with people who are solving the housing problem in Africa as well. And Africa is estimated to require almost 500 million houses by 2030. So this is a global problem, and we are working towards that. So before I speak with respect to what we are building, I think I would just like to speak about the partnership with Habitat for Humanity as well. Habitat has been doing a lot of work in India and across the globe in 70 countries with respect to housing. And with the Shelter Tech Accelerator, what we have actually received is an opportunity to really understand the housing problems, not only from what we have been able to gather, which is really minimal. It is constrained by geography, it's constrained by how many people we are able to speak to. And Habitat has far more experience. And through the Shelter Tech Accelerator, we have been really able to understand what are the various problems that exist in housing, apart from just the construction aspect. And also, how do we do that in a sustainable manner? And how do we do that for different markets? So that is something that we have been working towards.
That is wonderful, Adhitya. I think that's a great large goal. And what is the technology? Can you walk us through what you have developed by way of your technology and solutions towards this?
Sure. Yeah. So maybe before I get into the technology, I would just like to speak about the kind of impact that we are envisioning with our technology coming into the market. And these are two photographs that are very commonly used to emphasize disruption, and yet we sort of fail to understand what disruption could really be in any industry. So this is New York in the early 1890s, and this is New York 10 years later, after the advent of automobiles. And you can see the sea change that was driven within that city by Ford releasing the Model T. And this is the kind of innovation, this is the kind of disruption that we would like to bring with construction 3D printing. And it is really possible because this is one industry that has not really changed for almost 50 to 60 years at all, especially in a country like India. It has remained static for a very long period of time. So it would be very difficult for people to imagine what automation and construction can do, but it can drive productivity up really a lot. And we have a team of 20 very talented engineers who are working across disciplines, mechanical engineering, civil engineering, software, electronics, and also construction strategy. And the company, as I said, was started by three of us about 3.5 years back. So what we are actually building is a mass scale automation of construction, which is customizable. That is the only thing that you have to change to really print a different design is the BIM file or the digital file. So earlier you had to, manufacture new formwork, have new plans for designs, but here nothing is required. You just modify the BIM file, update it to a 3D printer, and we are ready to go ahead. We are trying to reduce the quantity of materials that we use to make our solution much more sustainable. And in terms of time, we are delivering an order of magnitude increase. It's not even a percentage increase. And we are working on reducing the cost with scale as well. That is, when we scale up, the cost will continue to reduce. And the technology that we have developed is really end-to-end, in the sense we have developed the 3D printer, the material, the software, and other solutions that are required for this. So I'll just probably go through the problems that we can really tackle. With respect to affordability, there is a problem of transparency and affordability in the market, even within the same geography. In especially a country like India, there is no transparent pricing for the same structure. And also, affordability becomes a problem when things are tied to many supply chains. So this is something that we are trying to change. We want to reduce the cost of construction considerably to 40%. Sustainability is an aspect that we are working on to reduce the amount of material that we use with construction. Productivity, as I mentioned, is the lowest in the construction space, and Indian labor productivity is the lowest among almost all major economies. So that is something that we are working on. And this is something that we are extremely passionate about, to deliver urban quality construction in rural areas. We want to ensure that there is no distinction between a rural house and an urban house. And anyone who has traveled into rural India will know that, the cities are constructed in a, I won't say a very good way, but in a particular way. And the rural houses are just put together. So in that sense, that is a major problem in this country. And speed, as I mentioned, speed is becoming a problem with respect to government's affordable housing program and affordable housing in general. So I'd like to change that. So these are 3D printers that we have built. That is currently hosted in Chennai, India. And these are production systems. We are manufacturing on-site systems and also off-site systems. So what is displayed here is an off-site 3D printer, which is hosted within a factory environment. And currently what we are doing is we 3D print modules and then they are assembled on site. We went ahead with this method in the beginning because the supply chains are easier to sort of handle when the 3D printer is hosted within a factory. We are moving towards on-site printing. In fact, our next project is going to be done on-site. And we have been successful in making our 3D printer supply chain independent. So in that sense, we are able to sort of transport our printer to faraway locations and start 3D printing immediately. And one of the key areas that we can tackle immediately is disaster relief. So that is something that we have a large project on. So I'd just like to take you through a video as well of our process. So as you can see, with 3D printing, we can create any sort of form without form work, without any support material. And hence we are really opening a new paradigm of designs to architects and designers. When designs are constrained by form work, especially in a market like India, it becomes unviable. One of the key aspects of 3D printing that we have been working on is to make it affordable. We have been trying to make the material as similar to normal construction concrete in terms of cost as possible, and we have been extremely successful. So we had to redesign the pumping system, we had to redesign the material delivery system to sort of achieve it, and we have been able to do that. Several of our patents are actually on the material delivery system as well. So our solution, as I mentioned, includes the 3D printer, which is a patent pending, and a material delivery system, which we have patented. And we have a proprietary raw material. As you might know, construction 3D printing cannot use normal concrete because the concrete has to take its own weight while being printed. So we have developed a proprietary raw material that can be used for this. We are also developing non-concrete materials that we are planning to use. And we have developed a software which can really enable BIM-led construction. That is, we can take a BIM file, We can clean it and we can directly use it with our software. I have a demo of our software coming up as well. And one thing that we are really working on is design for additive manufacturing. 3D printing offers so many advantages while building something that it would be a shame if we don't take advantage of that process. For example, in the video that you just saw, the modules that we were printing were not 100% solid. We could achieve the same level of strength with 45% infill or 50% material that otherwise would be, 100% while using conventional construction. So to take advantage of additive manufacturing or 3D printing, some modifications on the design have to be done. We are trying to do it by providing customers that experience, but moving forward, we would like to automate that process as well. So that is something that we are working towards. So this is the software solution that we have completely developed from scratch. Everything including the slicing, the viewing, editing designs, the cleaning of BIM models that can really enable architects to work with the software much easier. So these are aspects that we have done on the back end. The software can also completely track where the 3D printer is, how it is printing, what amount of material is left. So all the feedback mechanisms are sort of embedded into the software itself, and there is very good data logging and data analytical capability built into the 3D printer. So the 3D printer can correct itself in the middle if there are errors being generated during the printing process. Let's say because of any abnormalities in the material mix design or anything of that sort.
And this was completely done in-house by your team?
Yeah, so this software was completely built in-house by the team, and we are sort of improving upon it moving forward. We want to enable customers to have a direct BIM viewing capability, BIM interface capability. So this was done completely by the team, yes. Yes, ma'am. So that has been the technical journey of the team.
Yeah. So, we have 10 more minutes. So do we want to jump ahead into the current work you're doing? Because, sure. There was work in the past. Yeah. And, based on time, we can come back to this.
Sure. So I'll quickly maybe just say that this was one of the 3D printed structures that we did in the past. So we had a conference with the Ministry of Housing in India, who are trying to accelerate us through their procedures so that we can have regulatory approvals quickly. I'll just skip that particular video. So we are currently finishing a 3D printed house in India. We are doing this in partnership with Habitat for Humanity. So this would be India's first 3D printed house, but also this would be a unique structure with several unique shapes and unique features. And this is sort of, we are developing a template for making affordable housing possible in the country. So this is a 600 square feet house. 400 to 600 square feet is what is usually used within the affordable housing space. So we have a short message from the Vice President of Habitat.
Hi everyone, it's Patrick Kelly from the Terwilliger Center for Innovation and Shelter at Habitat for Humanity. We're passionate here about market-based scalable solutions for affordable housing. With almost 2 billion people in substandard shelter, we need the creativity and the innovation of startups and entrepreneurs. So we're very excited about Tvasta, an alumni of our Shelter Tech Accelerator, recipient of one of our catalytic grants, and are thrilled about the 3D printing technology and them bringing that to the issue of housing. We think Tvasta is positioned to build for $1 billion with their technology.
So thank you for the support that Habitat has been providing us. I'll just show you a short rendering of the house that is being built and take you through the actual process of the house that is being built. So this would be a unique structure. We wanted to showcase the uniqueness that could be bought in using 3D printing. That is why we have gone for a few irregular shapes. But at the same time, we have retained several aspects that would be standard across affordable houses. And we are building upon this to get our regulatory approvals for starting larger projects, much larger projects in the country. Yeah. Just to take you through a video of the construction process. So this, as I mentioned, is a off-site 3D printing project. That is, we have built the modules within our factory environment and we'll be assembling it. Our next project is on-site. Off-site 3D printing has got its advantages because in Indian urban landscape and also in Indian rural scenarios, not every site is really accessible with a 3D printer. So in that sense, off-site 3D printing would have a major role to play going forward as well, because we see that to be one of the most viable technologies, especially when large-scale production is involved. If 50, 60, 100 structures are getting printed at a time, off-site 3D printing would be the method to go. So there has been disruptions with respect to our construction process due to COVID. Few people have tested positive and we have not been able to finish it. But we are quickly planning to finish it within the next 5 to 6 days. The modules will be actually locked together using a dry joining process. So it's a very simple procedure. All the provisions for joining the modules together have been provided. So moving forward, we are integrating finishing processes into our 3D printing as well. So here finishing is done conventionally, in the sense plastering, etc. But moving forward, the printer itself would be able to take care of that. So that would be a huge added advantage because that's a very skill-intensive, costly process. So by reducing that, we are planning to reduce the cost of construction quite a bit as well.